Hello everyone, welcome to numerical series of physics, and today our numerical problem on work, energy and power. And this question is frequently asked in the board exam of ANEB. And the first numerical problem is: a bullet of mass 100 gram is fired from a gun of mass 2 kg with velocity 200 meter per second. Find the ratio of kinetic energy of bullet and gun. First of all, write all the given data. And the given data is mass of bullet m1 100 gram, that is 0.1 kg. Mass of gun m2 equal to 2 kg. Velocity of bullet after collision v1 200 meter per second, and velocity of gun after collision v2 equal to what? We have to find the velocity of gun after collision. We know the principle of conservation of linear momentum. Momentum before collision equal to momentum after collision. So m1 u1 plus m2 u2 equal to m1 b1 plus m2 b2. We have already m1 and u1 initial velocity is 0 and m2 2, and this is also the initial velocity. Uh, this is this m1 is a mass of bullet, so this is initial velocity of bullet, and m2 is mass of gun, so this is initial velocity of gun, and m1 u1 equal to m1 b1 plus m2 b2. m1 0.1 and v1 already final velocity already given, that is after collision. Plus 2 into v2. After simplifying this, we can get v2 equal to minus 20 by 10, that is minus 10 meter per second. Now kinetic energy of bullet, we have to find the ratio of kinetic energy of bullet upon kinetic energy of gun. So kinetic energy of bullet m1 half m1 b1 square plus 1 by 2 m2 v2 square. So after simplifying this, we can get our final value is 20 upon 1. So 20 is to 1. This is the ratio of bullet to gun. And next problem is a body of mass 5 kg initially of rest is subjected to a force 20 Newton. What is the kinetic energy acquired by the body at the end of 10 seconds? Mass given 5 kg, force 20 Newton, time 10 seconds. We know acceleration equal to force by mass. F equal to ma, so a equal to f by m, that is 20 by 5, 4 meter per second. Then velocity of body v equal to a into t, we already know. So v 4 into 10, that is 40 meter per second. And we know kinetic energy equal to half mv square. Put the value of m and v, we can get energy equal to 4000 joule. And similarly, next problem is a stationary mass exploits in two parts of mass 4 unit and 40 units respectively. If the larger mass has an initial kinetic energy of 100 joule, what is the initial kinetic energy of a smaller mass? We have to find the kinetic energy of this 4 unit. 4 unit is smaller, so we have to find the initial kinetic energy of a smaller mass. Mass of first part m1 4 unit, similarly m2 40 unit. Kinetic energy 100 joule. We have to find the kinetic energy of k1, that is of mass m1. So we know the laws of conservation of momentum. m1 m1 v1 plus m2 v2 equal to 0. So put the value, we can get 4 v1 plus 40 v2 equal to 0. This is equation 1. And a kinetic energy equal to half m2 v2 squared. Put all these value, you can get v2 equal to 5 meter per second. Substituting this v2 in equation 1, then you can get v1 equal to 10 root 5 meter per second, and k1 equal to half m1 v1 square, that is half 4 into v1 is 10 root 5, so this is a square of 10 root 5, that is 100 joule, 1000 joule. So required kinetic energy of a smaller mass is 1000 joule. And next one is a water reservoir tank of capacity 250 meter cube is situated at the height of 20 meter from the water level. What will be the power of an electric motor to be used to fill the tank in 3 hours? Efficiency of motor is 70%. We have to find the power of an electric motor. First of all, write all the given. Volume equal to 250, height equal to 20 meter, time equal to 3 hours. So 3 into 60 into 60, 3 into 60 into 60, then you can get this hour in second. And efficiency of motor is 70%. Power, we have to find P in input power of the motor. So mass of water filled is volume into density, that is 250 into 1000, that is 250000 kg. And work done to fill the tank, W equal to mgh. So we have already found the value of m, and z is 10, h is already given in the question 20, so you can get 5 into 10 to power 7. And when output power equal to work done upon time, so 5 into 10 to power 7 upon time we have already mentioned in the question. So 10800, and then you can get 4.63 into 10 to the power 3 watt. And we know efficiency equal to output upon input into 100%. After simplifying this, we can get input power equal to 6614 watt. And similarly, a stationary mass exploits into two parts, 44 kg and 4 kg and 40 kg. Initial kinetic energy of larger mass is 10. Find the this question is already done above. Similarly, both questions are same. And here we have to find the velocity. In the previous question, we have to find the kinetic energy, but in this question we have to find the velocity. So all the processes are similar, and in the last we can put k equal to half m1 v1 square, and we have already find the value of k. Then v square v1 square equal to 7.07 meter per second. So the velocity of a smaller mass is 7.07 meter per second. Similarly, next question is a ball A of mass 0.1 kg moving with a velocity of 6 meter per second collide directly with the ball B of mass 0.2 kg at rest. Calculate their common velocity if both ball move off together. If ball A has rebounded with a velocity of 2 meter per second in opposite direction after collision, what would be the new velocity of B? A mass of A m1 0.1, a mass of B m2 0.2. Initial velocity of ball A u1 equal to 6, and initial velocity of ball u2 equal to 0. After collision, both ball move together, hence let B be the common velocity. From the we know the principle of conservation of linear momentum, m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2. So put all these values, you can get B, and B equal to 2 meter per second. And second part, m1 equal to 0.1, m2 equal to 0.2, u1. This is first part. And in second part, since the ball A had rebound in opposite direction after collision, that is b1 equal to minus 2 meter per second and b2 equal to what? Again we can we have principle of conservation of linear momentum. Then put all this value, we can get b2 equal to 4 meter per second. And similarly, next problem is a typically car weighs about 1200 Newton. If the coefficient of rolling friction is mu r equal to 0.015, what horizontal force is needed to make the car move with constant speed of 72 km per hour on a level road? Also calculate the power developed by the engine to maintain this speed. First of all, weight of car 1200 Newton. Coefficient of friction 0.015, velocity 72 kilometer per hour. Then convert this into meter per second, we can get 20 meter per second. Power developed by the engine, P equal to what? And we will also find the horizontal force. We know F minus F equal to m, A equal to 0 when horizontal force, F equal to horizontal force, and F small f equal to frictional force. F equal to F equal to mu r mg. Mu r equal to 0.015 into 1200, that is 18 Newton. And power developed by the engine, P equal to F into V. So F is 18 into 20, 316 watt, and horizontal force is 18 Newton, and power developed by the engine is 360 Newton.